Okay, so here we are, packet 5, class number 8, Tuesday the 23rd. The main thing we're going to hit today is land. We're going to come back to a land error problem. This time we're going to do it with type 2B. And this is one of the top 10, I think, I could say hardest problems of the year today. So you came to the right place. This week is test week. Now it's a little different for you all. Yours is this for virtual. Yours will be available at starting at 2 p.m., let's say, up through 6 p.m. Saturday. It's due. You have to, so I'm not going to make you come to my front porch. I mean, the weather's not bad anymore, but I'm trying to, that whole weather thing kind of made me think about it. I'm thinking, well, what if a kid has a wreck on the way over or trips over my front porch? And so the district's going, hey, Asky, you shouldn't have kids come to your house. Okay, and you can always voluntarily do it, but I'm not going to make you. So I'm not going to make it so you have to. So I will, because of that, I will put the test on PDF and email it to each of you. Now, Ansley, I may forget to email it to you because you're not on my list, but you might want to just remind me if you don't get it by 2 p.m. So 2 p.m. Friday, you'll get test 4B, which has nothing to do with what we're talking about today. That's 2 weeks ago. But let's go back and look at this. Let me get ahead of myself. So last night, I had only 6 students there at the virtual, not the virtual, but the Zoom help session, 9 or 10 p.m. And I was kind of upset. I had, what, 6 students out of 73? Come on. But then when I went on the YouTube channel, I realized, oh, we'd already done one. That's probably where most of you were. So why go again? But we did talk about different problems. I only had 6 students, so I could really individualize it to them. And we mostly looked at like problem 13, which is a tough one, problem 9, basically the 3 or 4 hardest problems we just spent the whole hour on. So if you want to go back and watch that again to prepare for the test, and I didn't waste their time. I mean, I was throwing out Easter eggs, right? Because I was happy they were there. So if you want to watch that, that's available. This is available on the YouTube channel, and it's available on, you know, all the different 3 places. Tonight, even though your test is not till Friday, you got to submit with everybody else. You got to submit your take-home test 4B. Most of you already have. And if you want to resubmit it, you can do that without any kind of penalty. Wednesday is when I'll post at 2 p.m. We are going to meet together Wednesday, but then at the end of our meeting, I'll post the key, my video key for take-home test 4B. I'm going to hedge my bets. I'll say 3 p.m., but just to be sure that I have time to, I don't know what I'll do tonight. And then tomorrow night, you want to study for the test. Tomorrow and Thursday nights, you'll study for the test. So when you take the test for virtual students, when you take the test on Friday, now we're not going to meet on Thursday. We're not going to meet on Friday. So no virtual Zoom on those 2 days, here or here. So just today and tomorrow, and that's it for this week. But we didn't met yesterday, I guess. So they do feast and film, but what you're going to, so then on Friday, you'll take that 300 point test 4B. And you look at that, that means like problems are worth anywhere from 20 to 50 points each. So it's pretty intense. But that's going to be Friday, Saturday for you. And then now here's where the whole porch thing comes in, because you have a packet to turn in and your notebooks. And so I leave it to you. If you want to take a picture of every one of those, I prefer you turn them into PDFs. Definitely testy to be PDFs. I guess I don't have to have, like you could do pictures for packet and for notes, and then just submit all the pictures at once on, email. Or if you just don't want to do all that hassle and you're driving around town anyway, I'm fine with you dropping it on my porch Friday or Saturday. Okay. So questions on that. So we're looking at Friday, Saturday for you is 300, 455, 525 points. Yeah, 525 points. Oh, also one more thing before you ask questions. For you all, for virtual, you have to give me, there is something for you to turn in, and that is sheet 5.2. Because all along, the in-class students have been getting dino stamps. Actually, they haven't. They're getting them all tomorrow. So that's worth like 40 some odd points. So I'm making this worth like 45 points. So sheet 5.2 needs to be completed by you. We're going to do the last problem today. It needs to be completed and submitted. Submit, okay, by midnight, tomorrow night. And I think that assignment, you got that assignment. Okay, so kind of a crazy week. Things will settle down next week, I promise. Any questions on this week? Okay, well, if you have individual, you can always stick around at the end and ask me. This is still the status of your test right now. I'll wrap it up tonight and get it down. I got it down to, I think, what I'm going to have my 2 pages, but I pull from these, every one of these little boxes is a page. So I pull from these 432, some are blank, but I pull from this is in my source to make a test. And I'll finalize that tonight. And then, okay, there's the, tomorrow we'll watch in class anyway, and I'll put the link for you guys. We'll watch some live video of the landing of Perseverance. This is what for you all, like I say, it's Wednesday at midnight. This is them. This is their dinosaurs. Tomorrow, big dinosaur day in class as I'm going around giving stamps. I didn't do it today because some students didn't even have their packet yet because, they couldn't get it. Now, packets are on my front porch. I'll add some more to it. I'm about out of them now, but I'll add some more if you want to come by. Or you can just print them all off if you want. Joke Monday, can't redo that here. So let's go ahead and get into this. We've done type 1, we've done type 2. Today we're working on we're a little bit on type 2, and we'll do a little bit on type 2B. So we are going to be looking at this. You really need to this is page 10, but you need to familiarize yourself with the 10 sheets, the 10 equation sheets, so that you only get yourself an hour. You're on the honor system, but you're supposed to put a stopwatch there and give yourself an hour to take the test. That's only being fair to all the in-class students that only get 55 minutes, really. And then you submit it. So I'm not saying it has to be, I'm not saying you don't like download it off the email, take it and submit it all within an hour. You can download it and then print it off. Unless you have an iPad, you have to print it off somehow. I suppose I can put some paper copies on the porch if you don't really have access to a printer. One kid told me that the printer ink froze at their house. So I realized everybody has issues. After I'm done here, I'm probably going to work on my busted up laundry room after this. So I understand. But if you don't have access to a printer and you don't have an iPad, I will put some paper copies of the test on the porch. You can just drive by and pick those up Friday if you want. All right. And there'll also be, I've already given you all on the front porch, there was sets of 8 equation sheets. Now there's 10. So I'll put sheet 9 and 10 on there too. So we've seen this before. We've done these, and now we're working on these. Okay, so one thing I wanted to point out is when like a hammer, and in class I threw this gavel in the air and it rotates, but still what you're looking at is the center of mass. Really just concerned with the center of mass. And if you follow the center of mass of an object or objects, it will follow that parabolic path. Gravity only really cares about, sometimes it's called the center of gravity. And they'll say, well, what's the CG of the system? What's the center of gravity of the system? So it'll follow gravity affects just the center of mass of an object or a system of objects. And here's an example of a system of objects. This dirt bike guy going over a hill, and I don't know whether he jumped off on purpose. I don't think he did. But if you follow the center of mass of the system, like between him and the motorcycle, there's a center of mass, and it's shown with an X circle around it. Between him, X circle around it. So you find the center of the mass of the motorbike, center of mass of him. Notice it's skewed towards the motorcycle because it weighs more. So and we'll do center of mass problems, a few. It's a way to solve some system problems quickly using center of mass. But the point is that the center of mass of a system continues to have that parabola. If I follow him only, I come up and the parabola gets elongated. If I follow the motorcycle only, it comes up and gets truncated. You see what I'm saying? But the center of mass is still, in this case, it looks like it's about type 2B probably by the time he lands. For fireworks as well, fireworks go off, they break. But if a firework, say a canister shot off at an angle, then all the fireworks come out. Say they breaks into 1,000 pieces. If you follow the center of mass of the system, it'll still go up and come back down as a parabola. It's kind of weird. You add up all the, in this case, momentums, which we're going to get to next week. Add up all the momentums of all the little particles, you still have a quote perfect parabola. I mean, there's air drag. But okay, so the homework was to work on number 8. And so we're going to work today, and I'll post a key to this after you've turned in you've submitted. So the key will be posted like, probably this is out of sight, out of mind Friday because of all the testing, and Thursday. But this weekend, the key will be posted. So we're going to spend the majority of this time on number 9. It's like number 1. If you go back and look at number 1, and number 1, we saw it's a land air problem. But number 1 was the simpler version of it. This one right here. We did this last week, I think. So that is kind of the same idea now, but now it's complicated because now we have angles involved. So this is type 2B. We don't get all those breaks we get. So the first thing I want you to do, and I'm going to turn the camera off. I'm going to turn, not the camera. I'm going to stop recording. And I want you all to first try your best to draw a required label drawing. Now on that label drawing, it's got to have all the data. It's got to have all the details here. You got to have all the numbers and what they represent. So that's 30 degrees. So we're looking for 30 degrees below. We're looking for, what else we know? Blah, 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 blah. Constant acceleration. So we have acceleration. We got delta X. We got delta Y. So all these things, I better colorize this. This is delta Y, which is in blue. This is delta X, which is in orange. So in one problem, we're going to have the red equation, the orange equation, and the blue equation. Okay, so I'm going to pause it here so we don't bore the people watching the recording. And I'll give you a chance. Somewhere. There we go. All right, so we're back. The students have made their drawing on their paper. And this is the official drawing now. And so we have the orange on this drawing represents the land. The blue is the air. And so in the orange, we'll deal with this with orange equations, orange kinematic equations, because there is acceleration. And then in the air, we'll deal with it in red in the X and blue in the Y. So first order of business. Sometimes there's all kinds of modification of this problem. Sometimes you work your way backwards, and you have to end up saying, okay, what was the acceleration on land? So you got to work, you still have the same three equations. Now you work your way the other way. But 75% of the time, you start on land and work your way towards. In class, I was rolling marbles off inclined planes and then onto the floor, showing that, okay, now we've done marbles rolling down inclined planes, but we've never then shown them be shot out the bottom and onto the floor. So I think in AP Physics, we do a problem where they have to do that. Then they have a target, and they have to hit the target, and they get points for how close they get. They have to predict. And we're going to be out in the hallway starting Monday, and we'll be doing stuff like that, but this time with launchers, launching things, and then they have to hit targets. And I'll show you a video of that. Okay, so we start with the orange. Let me darken that up a little bit. Start with the orange. And here we go. So we're not going to use this first orange, and we don't know V final on land. We don't know time either, so too many unknowns. That's the same reason we can't use the second orange. So when you don't know your time, you use the third orange. So, okay. So just write it out first. We have V final X squared, and you have space on your sheet to do it. I'll just do it right here. Equals V naught X squared plus 2A delta X. Okay, well, we catch a break. V naught is 0. It goes away. And so we're solving for V final, kind of like we did on problem number 1. So that is scroot 2A delta X. Plug in now. V final X then equals the square root of 2 times 15. So I had students go to the board, but what I noticed, and I go around and look at their work, and what I noticed was students would okay, I'll show you an example. So let's hold on for a second. So I'd go look at the board work, and I'd see this kind of stuff. I go, that's all they did. Well, I mean, you kind of miss the whole point to the board work. This is a graphic organizer. You've got to have every number in the problem because it has a place. We're dealing with 3 equations, folks. This isn't a plug and chug. You got to know what you're doing. That's what separates physics from math. I mean, we use math in physics, but all right. So I'll save you time. V final X then is 77.5, give or take, feet per second. And I got a couple of kids that are sticklers for some reason on Sig Figs, and they're calling me on it every day, saying, well, Mr. Askey, your Sig Figs, you're right. I mean, I'm a big Sig Fig guy if it's a Sig Fig problem, but this is not really a Sig Fig problem. Because if you look at the problem, they were pointing out that they said, look, you got 1 Sig Fig here. And I appreciate the, pointing it out. You got 1 Sig Fig here. You got 2 Sig Figs there. You got 3 Sig Figs here. And then you got 3 Sig Figs here. What is it? 1, 2, or 3? And okay, here's the deal on Sig Figs. Unless it's a Sig Fig problem, which by the way, we don't do on AP Physics anymore. But the AP and the AP Physics exam does not really push Sig Figs. It used to. Now the only time they push Sig Figs is AP Chemistry. Even there, it's not that big a deal. I don't know why, but it's not. It will be a big deal when you get to college, in your junior level of college. But I guess high school, they kind of catch you a break. So my thing is, if I'm dealing with Sig Figs, which we don't really so much the rest of the year, maybe once or twice, we will actually Monday. Unless I'm doing that, I don't concern myself so much. Come on, man. I don't concern myself so much with SIGs. So the rule of thumb is 3 SIGs in the answer. Give me 3. 5 is too many, 1's too few, 2 okay, 3 is usually preferred. And that's worldwide. Okay, so 77.5, and that gets us to the edge of the cliff. Now we have to, okay, that's the link. Remember the link between the land and the air is right there. V final of the land equals V naught of the air. So land, air. All right. So that, though, is not Vx of the air. It's not Vy of the air or V naught y. It's this V. It's this hypotenuse. So I have a, let's go, we learned this first hour, we were kind of throwing it around. But second hour and third hour, I got smart and said, okay, let's just do our work right there on the triangle, right there in the drawing. Let's deal with our X and Y components. Boom, 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 boom. There's my X, there's my Vx. Vx, and here's my V naught Y. V naught Y. And so let's get that out of the way. We learned here that this X, this hypotenuse, is 77.5 feet per second. Okay, that's V naught. So therefore, Vx is 77.5 cosine negative 30. And notice that has to be a negative 30. It's going to kill you if you don't. It's going to really mess your numbers up. And then V naught y is 77.5 sine negative 30. Cosine, it doesn't matter. Looking at the unit circle. Okay, here let's just draw a quick unit circle. Boom. So looking at a unit circle, cosine is if I have an angle. Okay, some angle theta, and say it's 30 degrees. Okay, so my cosine is the length of, I'll go red for cosine. Cosine is the length of this side, right? Let me go black for the actual vector. So then the blue is the sine. Red is cosine. But notice if it's 30 degrees or negative 30 degrees, negative 30, it doesn't matter as far as cosine goes. It's not very to scale, but it's okay. Negative 30. Cosine of 30 or negative 30 is the same thing. It's that same red segment. But sine is positive because it's the vertical part of it, or negative if it's the, so there's sine, and there's cosine. Okay, so you can get away with making a mistake on your not making it negative 30 on the cosine, but you can't get away with it in the sine. And that is the number one mistake students make in this problem. Okay, so we have, make sure you're in degrees. We have not radians. So we have 77.5 cosine negative 30. And that's 67. So this is 67. Boy, they get to a lot of minutia on this problem. Devil's in the details. And that's feet per second in the X, in the Y, 77.5 sine negative 30. Parentheses, negative 30. Oh, of course, just half, right? Okay, 38.75. So we'll say equals negative 38.8 feet per second. Okay, with me so far? Questions? crucial. Now we're ready for the red and the blue parts. Get rid of that garbage. Garbage. So down here on the projectile motion part, we got red. So we got the delta X part and we got the delta Y part. Or just Y part. Y and X. Now X is red, so we have I have a couple of kids that are trying to follow along with colored pencils. I feel for them because I can quickly switch, but they got red, blue. I mean, they're really good students, so I think it's awesome that they're doing that. But because it is kind of the way your mind works, because there's so many, you've got to categorize so much of this with, and why not use colors, right? I mean, I could call it 1, 2, 3, but why not use colors? That's why I'm going to write a coloring book. The guy was interviewing me from the transcript. He said today, talking about Dane, and he said, well, what do you taught for 35 years. We need to beef up our science education in America. What do you suggest? I said, one thing I suggest is that starting in first, second grade, start teaching physics. I mean, with coloring, just coloring books and stuff. Send kids outside in sixth grade and have them walk and run and things we do on the West Lawn, and then come back in and try and, how can we represent this? And get them starting thinking visually. Don't teach them all the math. Like Brandon here has had calculus. He's not here today, but he's had calculus, and now he's finally taking physics. I mean, come on. You should be taking physics at Algebra 1 and geometry and Algebra 2. I doubt that'll make the transcript. All right, so back to this. So Vx is 67.1 feet per second. Because remember, it's going to be V naught cosine theta times t. And then delta x equals 60, I said 67.1 feet per second times t, but I don't know t, so of course I go to the y. And here's the problem. I don't have any shortcuts. So now we go to the blue quad. T is equal to V naught sine theta plus or minus the square root of this. I'm not arguing with you. It's tedious. I know it is. I know you're starting to zone out, but I can't help it, man. It's a tedious problem. Minus 2g delta y all over g. Now, I'm going to pause it again, and I want you to wake up again, splash the water in your face, and I want you to now, let's pause it. Okay, we'll come back. Those watching the recording, hit pause in your recording, and now plug in numbers here. And plug in numbers and tell me what do you get on your own. Okay, sorry about that. I'm going to come back and show that again. Sorry, but I forgot I wasn't recording. So what I'm telling them is, we have these graphs here, all these graphs, and the reason why there's 5 graphs per projectile motion problem is the trio is for the vertical stuff. So that's the blue stuff, and then the duets are the X stuff. So the duet stuff. So that's why there's 5 graphs per problem. So we're diagnosing that motion, the graphs of that motion. So this is a real synthesis problem, because it's all this. Come on, man. Okay, it's all this at the same time. So here we go. How much time do I got? Okay, we got 7 minutes. So let's do what we can in 7 minutes. Football has a hang time. So we have a time. We know how long it is, which by the way is a long hang time. Hang time, when you're watching a football game, the announcer will go, man, check that hang time out. And that means the amount of time that when the football leaves the foot of the punter and before the receiver catches it, that's called hang time. So you want to get a long amount of hang time. Ray Guy was this famous punter, and he had these enormous amounts of hang time, which allows your coverage to surround. When the receiver catches the ball, he's surrounded by defenders. He has to do a fair catch. So you're trying to avoid the return. So a punter who punts the ball maybe a long ways, but it's called you're out punting your coverage. He punts it a long ways, but the receiver catches it fairly quickly. Like the hang time is like 3 seconds, and so he catches it quickly, and he has time to make his moves before the defenders ever get there. So you want a punter who has a good hang time. A little football lingo. Okay, so he kicks it at 40 degrees. We know it should have been 45 to get the maximum range, but okay, 40 degrees. So quick drawing here. He kicks it off, punts it like this. There's my V naught. I don't know what V naught is, but I have V naught. That's 40 degrees. And then this the tau is total time of flight is 4.5 seconds. That's all. And from those two numbers, I'm supposed to get 5 graphs. What am I, a magician? Well, we can get, okay, here's a pointer for you. Let's say in March, test 5A, and you're out of time. Test 5A will probably cover 5.1, 5.2, 5.1 through 5.4. I'm guessing that'll be test 5A. Let's say that you're doing that and you're out of time. You're literally got 2 minutes left. What I would do, and we have 4 minutes left. Okay, say we have 4 minutes. So what I would do is, I know this is a type 2A, and yet how you got a kid asking class, how do you know it's type 2A? Well, the guy's punting the football at a certain height. The guy catches it pretty close to the same height. I mean, it would tell you. If you're punting a football off a cliff, it'll tell you, right? Or you're punting it up into the stands. So you're just punting it, so you assume it's level. You had to make that assumption. All right, so in the Y, I'm starting off at 0. That's the origin. It ends up back at 0 at 4.5 seconds, which goes a little bit off my graph. And I know then it's symmetrical, so I know at 2.25 seconds, halfway, it's going to be at its apex. So I'm going to turn this thing around. I'm going to do a little ruler here. And at 2.25 seconds, I'm going to do a vertical line. Okay, so I'm down to about 3 minutes. This represents the speed you're trying to get some points in this problem. I'm going to show you how to get out of a 20-point problem. I'll show you how to get about 12 or 13 without doing any work. So you know, okay, so you've shown that. Then you know, I don't know what the apex is, but I know that at some point it reaches the apex up here. I'm just going to pick a point, put a dot there, and then it's going to come up as a parabola. That's going to come down. It's symmetrical. There's the other side of the parabola. I know that my V versus T is going to be a perfect bow tie. So I don't know what the initial velocity is in the Y. I'll just pick a number. And then I'll take my ruler, and I'm going to draw myself a perfect bow tie because it's type. This is the type 2A. Type 2As are perfect bow ties.
Mr. Rasky,
Yeah.
wouldn't you move the dash line over a tiny bit if it's 2.25?
Yeah, you're right. I'm in a hurry. Daggone it. Okay. I'll give you a point on that one. You got me. Come on, man. I can't move over my. Hey. No, shoot. Okay, you're right. But I'm down to 2 minutes. I'm going for, many points as I can squeeze out of the teacher. So then the other one is the really low hanging fruit here. Here's a trick for you. Just draw a horizontal line anywhere, and then I don't care. There's no scale on there, and then just write -g, and that's good enough for me. I know what you mean. Okay. Now now you're getting some points. You're probably wrong. You're probably wrong here. You're probably a little bit wrong there, but you're getting some points. And then let's get some other points real quick. And that is on the, come on, man, hold on. That is, I've lost my ruler. Okay. Oh, well. See, that's when I get in a hurry. I'm like you know, you start screwing up. I understand. But, trust me, if colleges didn't make you do it, I wouldn't make you do it. Vx, I'll pick a number. I'm going to say that it's flat, right? Because it doesn't change. And then I know that X is going to then be linear. Okay, so if I'm coming along later and I'm going to grade this problem, I'm going to give you, out of 20 points, I'm probably going to give you around 12. 12, maybe even 13, maybe squeeze 14 points out of me. Maybe you get lucky. But see, the thing is, that's why you have to show your work. Here, you got to see work. So probably the best you gets 12 out of 20, but that's better than 0. Okay, well, anyway, tomorrow we'll go ahead and work this problem. Don't worry about this. Just ignore this tonight, and we'll deal with it tomorrow. And then really, it's not homework, this sheet, till next week. Okay. So that was a little bit of a tedious class. I apologize. But that some students, that was a top 10 problem there, difficulty. And some students go, oh my God, I mean, we got March, April, and May. It's going to get worse. Not really, not really, not really. Physics is like a roller coaster. It gets harder, 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 harder. All of a sudden we learn something new. Boom, easy, 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 easy. Then it gets complicated and start to add modifications and blah, 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 blah. Then it gets easy again. So it won't get easy, obviously, test, but next week, it'll go back to easy about Wednesday next week. It'll go easy for a while. Okay, so just hang in there. Okay. All right. I'm going to now stop the recording, I guess. And I will stay around. You guys can leave if you want. I'll stick around for questions.